Section 5.3, Part 2, Local and Global Extrema. With quadratic functions, we were able to find the maximum or minimum values of the function by finding the vertex. For general polynomials, finding these turning points needs advanced techniques from calculus. Each turning point represents a local maximum or minimum. Sometimes the turning point is the highest or the lowest point on the entire graph. And in these cases, we say that these turning points or this turning point is a global maximum or a global minimum. These are also referred to as the absolute minimum or the absolute maximum values of the function. A local maximum or a local minimum at x equals to a, sometimes we call these relative maximum or minimum, respectively, is the output at the highest or lowest point on the graph in an open interval around x equals a. So it's the same concept as quadratics. Applications. How are we going to use local extrema to solve some applications? Here is an example. An open top box is to be constructed by cutting out squares from each corner of a 14 by 20 centimeter sheet of plastic, folding up the sides. Find the size of squares that should be cut out to maximize the volume enclosed by the box. So here is an illustration of the sheet, the plastic sheet, and the portions that are going to be cut out. Notice that after we cut these squares out, the length, which is going to be 20, and the width is 14, is going to turn into 14 minus 2w. So this side is going to be 14 minus 2w. Here is 1w, here is 2w. So this is going to be 14 minus 2w. And the length is going to be 20 minus 2w because I have this cut out and this cut out as well and then folded up. The height is going to be the w because that is the height of the box. So using this information, the volume will be given by volume is equal to height times length times width. So the volume is height times length times width. Now we multiply these together. You will have w. When you multiply, you're going to multiply the binomials first. So first times last, last times first, last times last, and then you're going to distribute the w inside. And then you will end up with 280w minus 68w squared plus 4w cubed. Notice that some of the factors are w, 20 minus 2w, and 14 minus 2w. And the zeros are going to be 0, which is basically going to put w equals to 0 and solve. And then the second 0 is going to be 20 minus 2w equals to 0 and then solve. If you solve, you get 2w equals 20, which will give you w equals to 10. So that is the second 0. And then the third 0 is 7. So you're going to, again, set 14 minus 2w equals to 0. That will lead to 2w equals 14. Divide by 2, you get w equals 7. So here are the zeros by the factors. And because a height of 0 is not reasonable, we consider the zeros 10 and 7 only. So when w is equal to 0, we eliminate that because that is basically a height of 0 because w represents the height of the box. Now, we're going to use technology in order to sketch the graph of VW, the equation that we came up with here. We're going to use technology, maybe Desmos, in order to graph it. And then we can use this graph to estimate the maximum value for the volume, which is going to be this point right here. So that is the maximum value for the volume. From the graph, this can be estimated to be around 340 cubic centimeters, this one right here. So this is like approximately 340 cubic centimeters, which is the volume basically, because that represents the volume. And occurs when the W is equal to approximately 2.75 centimeters. So that is basically the height or the length of the box that needs to be cut in order to maximize the volume of this box. So we're going to say size of squares to be cut to maximize the volume enclosed by the box is 2.75 by 2.75. That is basically the length of the square times itself, which is basically the area that needs to be cut to maximize the volume. The maximum volume obtained will be approximately 340 cubic centimeters. So that is going to be the answer. In order to improve these measures, you can basically use an advanced technology. That is the end of section 5.3. If you have any questions, let me know.